In this video, we're going to try to determine if this series will converge or if it will diverge. So rewrite this series as this summation, and then multiply this out. That will then give us this. And we've seen this theorem in some of the early videos. We've already seen this theorem. So in order for us to decide whether this will converge or this will diverge, we are going to make use of number one. We are going to make use of this. So we are going to let this whole thing here be an. We're going to let this, and then we're going to compare it with something that we know a lot about. So as n gets bigger and bigger and bigger, we can think of this sequence as, well, n gets bigger and bigger. It's going to act like 2n on the numerator. On the denominator, when n gets very, very big, this is irrelevant, so it will just act as n squared. So this thing here is very similar to 2 over n. So when n gets very, very big, this whole thing here will act like this. So we are going to, so this bn here, we're going to let bn be 1. We are going to compare this. Well, we are going to compare this whole thing here to 1 over n. So this is a trick that we would use to decide bn here. We are going to compare it with this. So the thing about bn is that we know a lot about this harmonic series. So when n equals 1 here, this is infinity. The minute you see this, by now you know that this will diverge. We've done this many times. So remember, number 1 here says that if this diverge, then this will diverge. If this converge, then this will converge. But the thing is, we now created a bn here where we know a lot about. We know this thing here is going to diverge. We know this thing is going to diverge. So the only thing that's left is for us to check that this is satisfied. So because here we've created an am where we know it's going to diverge. We know that this series here will diverge from n equals 1 to infinity. So let's start all over again. We are trying to determine if this thing here will converge or if it will diverge. Well, when n gets very, very big, this whole thing here acts like 2n over n squared. Well, this thing here is very similar to 2 over n. Well, so we are going to let this whole thing here be an. But then we are going to deliberately create our bn. We are going to deliberately create our bn to be 1 over n. So this is the thing that we're going to use for bn. So this is our bn here. So now let's check this. If we get this divided by this, will it come to a number? Will it come to a number bigger than 0? So let's try and check it. So let an be this thing here. So let this thing here be an, and then let this thing here be bn. Let this thing here be bn. So hang on. So now we are going to check. We are going to check this. Okay. So let an be this thing, and let bn be this thing here. So now looking at this, an divided by bn. So an divided by bn. So does this come to a number bigger than 0? So let's check it. So hang on. So we are currently here. So let's rewrite this. Here we've got one thing divided by another thing. So let's just imagine that thing as timesing the reciprocal. So now top times top, that will then give us this, and then bottom times bottom, that will then give us this. So now as n gets bigger and bigger and bigger, this is going to be irrelevant. So the numerator will act like this. This is going to be irrelevant. So the denominator will act like this. So as n gets bigger and bigger, you can see the limit will be 2. You can see the limit will be 2. So looking at this, an divided by bn comes to 2, and 2 is greater than 0. So this part here is good. This part here is good. So now it comes down to this thing here. If this diverge, then this will diverge. That's what the theorem is saying. If this thing here is going to converge, then this is going to converge. But then if you look at our Bn, our Bn was this. N equals 1 to infinity. We know a lot about this harmonic series. It's going to diverge. So if this thing here is going to diverge, therefore this series will diverge. So our series will actually diverge because we know a lot about this. We can compare this to this thing, this complicated thing. Okay, so our series will diverge. So this series here, if you continue adding this whole thing up here, it will just diverge. It will just get bigger and bigger and bigger and bigger and so on.